Matrices, cofactors of square matrix for 2 by 2 and 3 by 3. Matrix and its element. A is a matrix and it's written like that with A, I, J. I is the row and J is the column, and has to be in bracket to indicate a matrix A. And here's the matrix A, 3 rows, 3 column. That's a 3 by 3 matrix. It can also be written as a matrix with a square bracket. Aij in bracket is the matrix, which is that, but Aij without a bracket is the matrix element. So each one of those is that. This is row 1, that's why this is 1, 1, 1. This is row 2, that's why this is 2, 2, 2. This is row 3, this is why that is 3, 3, 3. For column 1, 1, 1, 1. Column 2, 2, 2, 2. Column 3, 3, 3, 3. Each element in a matrix has its own minor matrix. The minor matrix of A11 is when we take A and we draw a line horizontally and vertically, and what's left is the minor matrix. So the minor matrix for A11 is this A22, A23, A32, and A33. That's the minor matrix of A11. The minor matrix for A12 is, again, we draw A12 and draw horizontal line and vertical line. So now the minor matrix for A12 is A21, A23, A21, A23, and A31, A33, A31, and A33. That's the minor matrix for A12. Minor matrix for A13, we pick A13, we draw horizontal line and vertical line. The rest of the elements are the elements in the minor matrix for A13. So the minor matrix for A13 is A21, A22, A31, A32. To find the minor matrix for A21, draw horizontal and vertical line to that matrix element. The minor matrix for that are the elements that are not on the line. So the minor matrix for A21 will be A12, A13, A32, and A33. Now you can get a picture. So let's try the minor matrix for A22. For element A22, draw the horizontal line and the vertical line. And any element not on the line will be the element for the minor matrix of A22. And the minor matrix for A22 will be A11 and A13, A31, and A33. So now let's do minor matrix for A23. We draw a circle. A23, draw vertical line and horizontal line. The minor matrix for A23, A11, A12, A31, and A32. Those are the elements in the minor matrix for A23. Each element has its own minor matrix. Now let's do minor matrix for A31. Draw vertical line, horizontal line. Any element left will be the element in minor matrix for A31, and that would be A12, A13, A22, A23. And now let's do minor matrix for A32. We draw a circle on A32, draw horizontal line and a vertical line. Any elements left will be in the minor matrix for A32. And we have A11, A11, A13, A13, A21, A21, A23, A23. For element A33, we draw a circle there, vertical line, horizontal line, and the minor matrix for A33 will be A11, A12, A21, A22. And to find the determinant of this minor matrix, it's going to be A33 times A22 minus A32 times A23. So the determinant will be A33 times A22 minus A32 times A23. That's how you find the determinant. That times that minus that times that. For this one as well, that times that, minus that times that, that times that, minus that times that. That's how you find the determinant of that matrix. What is a cofactor? First of all, we have a matrix Aij in brackets. Every element in a matrix has its own sign, and that sign is worked out from the formula here. So for A11, that would be 1, 1, A11 equal to minus 1 to power 1 plus 1. And that's how we work out the sign for each element in a matrix. And the signs are positive for A11, that's positive 1, that's plus 1. A12 is minus 1, A13 is plus 1. All the odd numbers are negative, and all the even numbers are positive. 1 plus 3 is even, so even number minus 1 to power of even number is positive, that's plus 1. And all the odd numbers are negative. That would be negative, that's why that's negative. That's negative, that's odd. 2 plus 3 is 5, that's odd, that's why that's negative. 3 plus 1 is even, that's why that's positive. 3 plus 2 is 5, that's why that's negative. 3 plus 3 is even, that's why that's positive. And why do we need to know the sign? We use the sign to work out the determinant. Also, we use the sign to work out the cofactor. So what is cofactor? Cofactor is the sign of an element, because each element has its own cofactor. So it's the sign of that element times the minor matrix for that element. The minor matrix we just worked out earlier. That's what is a cofactor. In this case, the sign has a formula. You don't need to remember this. You just need to remember that. To know where that comes from, this is where it comes from. Minus 1 to power I plus j. And then you times it by the minor matrix of that element. Quick example is to work out the sign of A22. That would be minus 1 to power 2 plus 2. So we're using these values here. 2 plus 2, that's I and j. I is 2, j is 2. 2 plus 2 is 4. And we get minus 1 to power 4. And that is plus 1. Or you could do this minus 1 times minus 1 times minus 1 times minus 1. Minus 1 times minus 1 is plus 1. Minus 1 times minus 1 is plus 1. And that equals to plus 1. That's how we get that plus for that one. As A22 is plus 1. So this is plus 1, minus 1, plus 1, minus 1. So that's the sign. And we needed those signs to work out the cofactors. 2 by 2 cofactors of a 2 by 2, 2 row, 2 columns. And we can represent that matrix like that in a square bracket beside the element position of the matrix and the sign of each matrix, plus, minus for a 2 by 2 matrix. And to work out the cofactor of element A11, which is that element, so that's a cofactor of element A11, and that will be equal to the plus 1, because that's plus 1, so that's plus 1, times, draw a line here, because we're looking at that element, that's the element A11, so we'll draw a line there and a line there, so that will be the minor matrix, plus 1 times 4, and that equals 4. So that's the cofactor of element A11. The cofactor of 1 is 4. Let's find the cofactor of A12, which is element 3. The cofactor of element 3 will be equal to, this is minus 1, so we have to put minus 1 here, times, so we come to 3 here, and we'll draw a line there and a line there, and we see 2 is not in that line, therefore the minor matrix of the element 1, 2 is 2. 2 times minus 1, that's minus 2. Let's try the cofactor of 2, which is A21. The cofactor of A21, which is element 2 here, will be equal to minus 1, because this is minus 1, times, so if you draw a line here and there, the vertical line along the 2 going to 4 and 1 here, then 3 will be the minor matrix of 2. So that will be times 3, and that equals to 3 times minus 1 minus 3. So the cofactor of 2 is minus 3. Now let's try the cofactor of 4, which is the A22. Again, this is plus 1, so that will be plus 1 times 1, because if you draw a line here and there, that is now looking at that, draw a line there, and that's 1. The cofactor of 4 is 1 times 1, which is in this case 1. Now we can write the cofactor of the matrix. Position A11 cofactor is 4, so we put 4 there, and position A12 cofactor is minus 2, so we put minus 2 there. The position A21 cofactor is minus 3, and the position A22 cofactor is 1. And that's how we work out the cofactor. But a quick way of doing this, if you had to do a quick questions 2 by 2 cofactor, is to swap, interchange these diagonal metrics here. That's what you can see there. Interchange them, you get 4, 1, and you interchange the diagonal here, but then you multiply by minus 1. So you interchange that and you multiply by minus 1. So that's minus 3, minus 2. But to show you're working, you've got to go through this process. If you have to do it for theory, when you have to show you're working, you have to show this method. But if you have to go through a quick question, then is interchange those and interchange the diagonal here too, but multiply this diagonal by minus 1. Cofactor for 3 by 3 matrix. If you have a matrix A, every element has its own sign, and that's positive 1, negative 1, positive 1, and that will be positive 1, that will be negative 1. So that's a sign of each element in the matrix. And to find the cofactor is equal to, so the cofactor of A11, and A11 is number 2 here. Number 2 is in A11, and that will be plus 1, because that's plus 1, times the, so what we do is we draw that one, and that will be 1 times 0 minus 4 times 6, because we draw a line here, we draw a line there, and so for 2, 0 times 1 minus 4 times 6, and that is that one, and that equal to, that's minus 24 times 1 is minus 24. So let's find the cofactor of A12. So the cofactor of A12 has an element of 3 in there, and we can say it's minus 1 times, all right, so you got here and you draw a line there and there, so you got 0 times 4 minus 1 times 6. 0 times 4 is 0 minus 1 times 6, and then times minus 1, that would be 6, because that's minus 6 times minus 1, that's 6. Let's find the cofactor of 5. That will be the A13, and that's got 5 in it, and so that is plus 1 times, so if you draw there and there to make the 5, horizontal and vertical to make the 5, then it's going to be 4 times 4 minus 1 times 1, which is 16 minus 1, and 16 minus 1 is 15. 50 times 1 is 15. Cofactor of 5 is 15. Let's find the cofactor of 4, which is A21. That's A21, and inside that A21, that element is 4, and this is minus 1, so we do minus 1 times, in this case, we're looking at that, so we draw a vertical line and horizontal line. So that would be 0 times 3 minus 4 times 5. So that's 0 minus 20, and that's minus 20 times minus 1. That would be plus 20. Okay, so let's do the cofactor of this one here, A22, 1 in A22. But A22 is plus 1, so we do plus 1 times a line there and a line there. That would be 0 times 2 minus 1 times 5, because that's 1 here, so that's A22, and that's what we got there. That's minus 5 times 1 is minus 5. A23, which is 6. Okay, so for that one, we can actually draw the line. So we got the 6 here, we draw horizontal line and vertical line, and so the matrix we've got is 4 times 2 and 1 times 3. That's the matrix we go for that one, and that is negative. 83 will be minus 1. 4 times 2 is 8 minus 3, that's minus 5. Cofactor for A31, and that's A31 there. Okay, we can pick up that A31, draw a line there, draw a line. Now we can see the matrix we're looking at is this one here. That's 6 times 3, that's 18, minus 1 times 5, that's minus 5. And this is positive, so we would have positive 1, 18 minus 5, and that equal to 13. A32, That's A32. So I could pick up A32 there, draw a vertical line and horizontal line to that element. And what's left are the minor metrics, which is 6 times 2 minus 4 times 5. And that sign is negative, that's minus 1. So that equal to, well, 4 is that element. That's 12 minus 20 equal to 8. And finally, we need to look at that element A33. That element, draw a vertical line and horizontal line. And you can see what we've got left. We have 1 times 2 minus 4 times 3. We're looking for plus 1, that's plus 1. 2 minus 12, because 1 times 2 minus 4 times 3, and that equal to minus 10. Now we go to cofactors and replace the elements with their cofactors. So for the cofactor of matrix A, we would have minus 24 plus 6 plus 15 plus 20 for A21, minus 5, and 13, 8, because A32 is 8, and A33 minus 10. And that's the cofactor of that matrix. We can use the cofactor to find the determinant, because to find the determinant of this matrix, it will be that times the 2 element, plus 6 times 3, plus 15 times 5. That will be the determinant of that matrix. We also use the cofactor to find the adjoint of a matrix, which is then used to find the inverse of a matrix. The transpose of a cofactor, we give it the adjoint, and adjoint over the determinant of a matrix is the inverse of a matrix. Here's an example, and try it and see what you get. Okay, so we have the element position numbers, and we know that they have signs, and their signs are positive, negative, positive, negative, positive, negative, positive, negative, positive. And the cofactor of A11 is minus 21, cofactor of A12 is 7, cofactor of A13 is 14, cofactor of A21 is 0, cofactor of A22 is 11, cofactor of A23 is minus 22, A31 is 7, of A32 is minus 17, A33 is minus 1. Now we need to replace the matrix element with the cofactors. So cofactor of A will be that